Last section in Module 3. We are adding, subtracting, and multiplying radical expressions. Okay, so when we want to think of adding and subtracting when we're dealing with terms, we always combine like terms. It's going to be our first fill in here. So we're going to treat radicals the same way that we treat any term with an x. So we will add the coefficients and keep the term the same. So for example, if I had a 2x plus 5x, I would add 2 plus 5, and that would give me 7, and I would keep the x the same as just x. So when we deal with radicals, we do the same thing. So for example, 3x and 2x would give us a 5x, but we would not be able to add 2x and 3y because they have different endings. Same thing with radicals. So if I have 3 root x plus 2 root x, since the root x is exactly the same, I combine the 3 plus 2 and get 5 root x. So I just add the coefficients in front. I do not change anything after the numbers. However, when I look over here at 2 root 7 and then 3 cube root 7, they do have the same radicand, but because the index is not the same, this is cube and this is square root, I cannot add them. So there I would just leave that the same as 2 root 7 plus 3 cube root 7. So when you're adding radicals, in example 1, first thing we do is we look at this and we say, okay, well 27 and 75 are clearly not the same underneath the radical, so I cannot add them. But you want to simplify each radical, and then if you can possibly, after simplification, add the radicals, then you would go ahead and do that. So let's look at simplifying each radical. Let's remember what our perfect squares are. So remember we have 4, 9, 16, 25, 36, 49, that would give us a 7 squared, then 8 squared is 64. Then we have 9 squared, 81, 10 squared, 100, 11 squared, 121, 12 squared, 144, and we'll go up to 13 squared is 169. So we'll go 14 and 15, 14 is 196, and then 15 squared is 225. Do any of the numbers on this list go into 27? Nine goes into 27 3 times. So we take this and we split this into root 9, root 3, because remember from our rules of multiplication, we can do 9 times 3. That just gives us a 27, so we're making a factor tree out of this. Take the square root of 9, which is 3. So we rewrite this as 3 root 3. Okay, then you go to the 75. Do any of the numbers on this list go into 75? $25. How many times does 25 go into 75? 3. So I make a factor tree again. Square root of 25, square root of 3. The square root of 25 is 5. So I make that 5 root 3. Bring down the plus sign. Now I can add these together. Okay, so I have 3 plus 5. I can add them because the square root of 3 is the same term. So I do 3 plus 5 and I get 8 square root of 3. Now, the way that we can check these is we can look on our calculator. Okay, add them. I can say, okay, square root of 27 plus square root of 75 is going to give me 13.856. And then here I can go 8 square root of 3 should give me the same exact number. Okay, and it does. And then if it gives you the same number, then you know you've simplified it correctly. Okay, but we're not interested in what the number, this exact number is. We want the simplified version. But that's just to check to see if your simplification was correct. All right, next page. We have problem here. Square root of 48 plus 2 times the square root of 75 minus 3 times the square root of 50. So we'll start with the 48. Do any of the numbers on the list from the previous page go into 48? And usually what I do is I start, okay, what number on that list is less than 48? Well, 36 is less than that. That doesn't work. Then 25, and then just go up that list. So it was 25, then 16. That works. So 16 goes into 48 3 times. Okay, keep them under the radical. And then take the square root of 16. That's going to be 4. So you get 4 root 3. Okay, then you have your 2 times the square root of 75. So we'll deal with the 2 in a minute, but we'll do 75. We already did that one, right? That was 25 and 3. The square root of 25 gave us 5. Now, when I have a number in front of the radical like this, that's multiplication. So I'm going to bring this down right here, and I'm going to do 2 times 5. And that's going to give me 10 root 3. And then there's a plus sign in between those. Okay, then I have my 3 root 50. What goes into 50 from that list? 25. 25 goes in 2 times, and the square root of 25 is 5. I bring down the 3, and I do 3 times 5, and then I have my square root of 2. So this will come down as 15 root 2, and then bring the minus sign down. Now we simplified all the terms. Which ones can we add? Yeah, I can only add these first 2 terms because they have the same ending. The root 2 I can't add. So here I have 14 root 3 minus 15 root 2. That's as simplified as I can make this, and sometimes you can't simplify it into one nice, concise number. That's okay. And then let's just go ahead and check that. So original problem was square root of 48 plus 2 square root of 75 minus 3 square root of 50. And that gives us 3.03 or 036. And then 14 root 3 minus 15 root 2. Same number. All right, example 3, now we have some letters underneath the radicals. So this goes back to what we did in Module 3, Homework 3. So let's simplify each of these separately. So I'm going to take this 16ab to the 5th, and I'm going to break it into, so I've got a cubed, then I have a root 16, I have a root a, and I have a b to the 5th. Okay, so I can take the square root of 16, that's just going to be 4. So that's good. And then the root a, I can't simplify that because there's no exponent on there, so that'll stay. But b to the 5th, okay, I can do that. So if we remember what we did last week, we took this, we used TIBO to convert that to b. The top of the fraction came from inside the radical, so that's 5 on the top. The bottom of the fraction came from outside the radical, that's an understood 2. So that gives us b to the 5 over 2. As a mixed number, what is 5 over 2? 2 and 1/2. Okay, so then that will turn into a b squared, b to the 1/2. Okay, so the b squared will stay outside the radical. B to the 1/2 will go back into the radical. So this will become square root of b. Okay, because the inside of the radical, or the top of the fraction goes inside the radical, bottom outside. All right, so now I got all this stuff here. I've got an a cubed, I have a 4, I have a square root of a, I have a b squared, and I have a square root of b. So if I put this all back together, I have the number first, then I have a cubed, then I have b squared, and then I have my radical, and I have a and b underneath the radical. Okay, now we're going to go to the next term, 49, a to the 7th, b to the 5th. So let's split that. So we have square root of 49, square root of a to the 7th, square root of b to the 5th. All right, square root of 49 we know is 7. We'll go ahead and do that. B to the 5th we already did over here, so we can do the same thing that we had there. That was b squared and b, right? Okay, we're just carrying that over from what we did in our first term. Now a to the 7th. Okay, so we want to convert a to the 7th into a to the top of the fraction comes from inside the radical, bottom of the fraction outside the radical. It's an understood 2. 7 over 2 turns into what is the next number? 3 1/2. So that is an a cubed, a to the 1/2. 1/2 goes back into the radical, square root of a. So now again, I've got a 7. I have an a cubed. I have this b squared. And then underneath the radical, I have ab. And there was a minus sign in between. Is this ending exactly the same as this ending? I've got a cubed, b squared on both, under the radical ab. So yes. So I do 4 minus 7, which is negative 3. And then I copy the ending, a cubed, b squared, radical a, b. Okay. Let's look at example 4. So now we have fractions, so let's deal with those. So I'm going to take the fraction, I'm going to separate it in the top and the bottom. So this is square root of 63 over square root of x squared. What's the square root of x squared? That's just x, yeah, because this is 2 over 2, which is just going to give me x. Okay, but 63, I'm going to have to take that and simplify that. So let me see here. Perfect square that goes into 63. 9, good. 9 goes into 63 7 times. Square root of 9 is 3. So this is going to be a 3 root 7 over x. Let me write that down over here. Okay, now let's look at this guy over here. So we've got a square root of 7 on the top, and then the bottom, square root of 9x squared. What's that going to be? What's the square root of 9? Yeah, square root of 9 is 3. Square root of x squared, x. So that's just 3x. Okay, so now I'm adding this. Okay, when I add fractions, I need a common denominator. What would be the common denominator for x and 3x? 3x, yeah. So that means I need to take this fraction, I need to multiply by 3. So if I go here, that's going to give me 3 times 3, 9. So I've got 9 root 7 over 3x plus root 7 over 3x. Okay, I'll rewrite it so you guys can. Okay, so what would this, can I add these? What's understood in front of this root 7? A 1. What's 9 plus 1? 10 root 7 over 3x. Okay, there's one on the next page I want you guys to try. I'll give you a few minutes to work on that, and then we'll go over it before we move forward. Okay, let's take a look here. Okay, so immediately looking at this, I'm noticing that 144, 81, and 121 are all perfect squares. So I can go ahead and pull these out. Square root of 144 is 12. So this is 12 square root of x cubed. This is going to be 8 times square root of 81, 9. So 8 times 9 is 72. Square root of x cubed minus 11 square root of x cubed. Okay, we can add these all together at the same time now, or we can do it at the end after we simplify everything. I'm going to go ahead and do it now, and then simplify the x cubed at the end. So 12 plus 72 minus 11 is going to give me 73. So I get 73 square root of x cubed, and I could do that because they all have the same ending. Now I need to take the square root of x cubed and simplify that. So that's going to be x to the top would be 3, bottom 2. Because this, remember, is square roots and understood 2 on the outside. 3 over 2 is 1 and 1/2, which means this is x to the first, x to the 1/2. X to the 1/2 goes back into the radical. With the x, the top of the fraction goes inside the radical, bottom outside. And we don't need the 1, that's understood. We don't need the 2, that is also understood. Okay, so this is just square root of x. So our problem is, if we bring down the 73, you have 73. Then you have your x to the first, so just x. Then your x to the 1/2 became square root of x. So 73x square root of x. Okay, so that's adding and subtracting. Now let's go on to multiplication. Okay, so we add coefficients of like terms. Another rule here, if the number of copies is equal to the index of the radicand, then you just get the radicand. So if I do square root of 7 times square root of 7, that's just going to give me 7 because there's 2 of them. And the reason why is because of this. Square root of 7 times square root of 7 is the square root of 49. And what's the square root of 49? 7. Same thing here, cube root of 7, cube root of 7. There's 3 copies. That's going to be cube root of 7 times 7 times 7, 343. I think that's 343. Yeah, and the cube root of 343 is 7. So that just gives us 7. And then here, you always want to put the radicand at the end. Okay, because you could write that and then go down to your next line and think that that's 25. But that's really 5 times the square root of 2. So that's going to go at the end. So you would do numbers, then letters, then your radical. So multiplying radicals, you're going to multiply underneath the radicals, then you're going to simplify and combine like terms if you can. So for our first example, we have square root of 2y times square root of 2. I'm going to distribute that. That's going to be under the radical, 2 times 2, 4, y. Copy the y over. Okay, then minus square root of 2y times y would be 2, would carry over, y times y would be y squared. Okay, then we would simplify each of these. So this would be square root of 4, square root of y. And of course, the square root of 4 is 2. So it's going to be 2y, or 2 square root of y. And then this is going to be square root of 2, square root of y squared. Square root of 2 is going to remain, but the square root of y squared is y. So I'm going to put that down. And I'm going to put the y first. The radical is going to go last. So y square root of 2. Now, are those like terms? It's tricky. You want to say they are because they've got the same letters, but they're opposite. So what's under the radical is different. So they are not like terms, which means that's it. That's the answer. That's a bad circle. Okay, let's look at a couple more examples. So example 1, you have square root of 7 minus square root of 2 squared, which means we're going to have 2 copies of this. So we're going to write it out with the 2 copies. So square root of 7 minus square root of 2 times square root of 7 minus square root of 2. And that's 2 binomials. So what do we do with 2 binomials? FOIL. So you have square root of 7 times square root of 7, which should be just 7, but you can write it out if you want as square root of 49. Square root of 7 times negative square root of 2, you're going to go minus square root 7 times 2, 14. Okay, then my 2 inside terms, again, 2 times 7 underneath the radical with a minus. That's going to be 14. And then my last, I have the negative times negative, which makes positive. 2 times 2 will give me 4. All right, so the square root of 49 is 7. The square root of 4 is 2. And then I bring these down. Okay, so my like terms, I have 7 plus 2. That's going to give me 9. What about these? What's that going to give me? Good. Negative 2 square root of 14, because this is a negative 1 minus 1, which is negative 2. Can I simplify 14? Are there any perfect squares that go in? No. Okay, only perfect squares that are less than 14 are 4 and 9, neither of which go in evenly. Okay, let's look at example 2. Again, we're going to FOIL. So we have a first term of 4 root x times first term of 9 root x. So 4 times 9 is going to give me 36. And then under the radical, x times x is x squared. Okay, then our outside, 4 root x times negative 4. So 4 times negative 4 is negative 16. Square root of x just carries over. Our 2 inside terms, 9 times 9 is 81. And then you carry the square root of x. And then you just have normal terms here. 9 times negative 4 is negative 36. Okay, so what here can we simplify? X squared. Square root of x squared is just x. So this is going to be 36x square root of x squared, but then that's it. Any like terms that I can combine? Yeah. Negative 16 plus 81. Thank you. Excuse me. Okay, so that's going to be a positive 65 root x. And then what about the 36x minus 36? No, because this 36 doesn't have an x. So That's it. Again, my answer is more than one term. That's okay. From here on out, you're going to see a lot more of that. All right, and one more example. Again, we're foiling. So let's see here. You've got a 3 on the outside, so the outside 3 will carry down. The inside 3s we're going to multiply, so that's going to be 3 times the square root of 9. Okay, then here on the outside, 3 times 7 is going to be 21. And then 3 times 2, 6 under the radical. Then inside, this outside 3 will carry, so minus 3. And then inside 2 times 3, that's going to be 6. And then negative 3 times 7 on the outside, so negative 21. 2 times 2 under the radical will be 4. Okay, so the square root of 9 is 3, so this becomes 3 times 3, which is 9. And the square root of 4 is 2, so this becomes 21 times 2, which is 42. And then my two middle terms, they have the same ending. So I can add those. 21 minus 3 will give me 18. And then I want to do 9 minus 42, because those are both just numbers. So negative 33. So negative 33 plus 18 root 6. You could do 18 root 6 minus 33 too, but typically we put the radical at the end.